right? So we have 2 to the power n subsets of an element, right? Of a n element set. So let's suppose you have a set of 20 elements, right? So there will be 2 to the power 20 subsets, which contains, say, suppose you have 1, 2, 3, right? So there will be 2 to the power 3, which is equal to 8 subsets, which is empty, then just 1, then 1, 2, and so on, right? ऐसे सारे subsets बनेंगे, right? There will be 8 such subsets of 8 3 elements. And we can try and generate all possible subset sum also. Subset sum का idea सबको पता है क्या होता है subset sum? कुछ नहीं, create each subset. We have 1, 2, 3. Create the subsets and create its sum. Okay. Create all the subsets and create its sum. Okay. So a subset will be nothing, then just 1, then just 2, then just 3, then just 1 and 2, then 2 and 3, then 1 and 3, then 1, 2, 3. There are 8 subsets. Creates its sum 0, 1, 2, 3, 3, 5, 4, 6. This is the subset sums of all the things. पेयर बना के नहीं, मतलब जो भी सबसेट में उन सब एलिमेंट का सम को सबसेट सम बोलते हैं, राइट? सो पॉसिबली वी कैन जनरेट ऑल पॉसिबल सबसेट सम ऑफ ऑल द सबसेट्स फ्रॉम द ओरिजिनल सेट. ये आइडिया समझ में आ गया कि सबसेट सम किसको बोलते हैं? क्विक +1 इन द चैट कि ऑल पॉसिबल सबसेट्स लिखा, उनके जो सम्स है, ये जो कलेक्शन ऑफ 2 टू द पावर 8 एलिमेंट, 2 टू द पावर 3 एलिमेंट्स है, व्हिच इज इक्वल टू 8, इसको बोलते हैं सबसेट सम्स. ओके. अच्छा, if we have n equal to 20 elements, so 2 to the power 20 subset sums बनेंगे. Even if a of I is up to 10 to the power 9, क्या हम सारे subset sum generate कर सकते हैं? Yes or no? By doing some sort of brute force कि take or not take, take or not take, take or not take. तो 2 to the power 20 options iterate करके we can generate all 2 to the power 20 subset and find all their sums individually. मतलब subset पे जाएंगे and find out its sum and put it in some sort of vector. एक वेक्टर या सेट में उसको पुश कर सकते हैं. सो वी कैन जनरेट ऑल पॉसिबल 2 to the power 20 सबसेट. इज दिस करेक्ट? इज दिस क्लियर टू एवरीवन कि ये पॉसिबल है कर पाना? दैट इफ देयर इज अ 20 एलिमेंट सेट, वी कैन जनरेट ऑल ऑफ इट्स सबसेट and we can generate all its subset sums. Okay. Now the catch is, suppose I tell you, can you find if there is a subset sum having sum equal to, let's suppose, x. For example, if I ask you, of this set, is there a subset having sum equal to 6? Yes or no? है कोई सबसेट जिसका सम x है? Give me quick 1 sec. Is there a subset? Give me quick 1 second. Give me quick 1 second. Okay. I think some people had a little bit of issue on joining the session. I feel, right? Let me just see. Okay. I think इसलिए 10-5 मिनट पहले आके बैठा हूँ. No worries. It was showing invalid ID. Okay. I think there might be some change possibly. Okay. Traffic. Okay. ठीक है. Latest link is valid. Okay. ग्रेट. तो बेसिकली व्हाट वी वर डिस्कसिंग वाज सबसेट सम, राइट? कितना कर कितना करा दिया भैया आपने? अरे कुछ नहीं कराया, टेंशन मत लो, अभी बस बेसिक से स्टार्ट ही कर रहे थे. जो कराया, मैं ज्वाइन नहीं हो पाया था. ओके, ठीक है, कोई टेंशन नहीं है, विल स्टार्ट. अब तो लिंक का इशू नहीं हो रहा ना कुछ को कुछ? ओके, या दिस इज फॉर मिक्स, दिस इज ओपन ओपन सेशन. ठीक है, दिस इज ओपन सेशन. ठीक है. बेसिकली हम लोग क्या डिस्कस कर रहे हैं? थोड़ा सा थ्योरी कवर कर रहा हूँ, मोस्टली तो प्रॉब्लम्स ही प्रैक्टिस करेंगे. ठीक है. तो मीट इन द मिडिल में बेसिकली कंसेप्ट वही है. नहीं नहीं, कोई लीड नहीं हुआ, टेंशन मत लो. सिंपल है. लेट्स स्टार्ट फ्रॉम बेसिक्स, जहां पर हम लोग स्टार्ट कर रहे थे. एक सेट दे रखा है, उसके 2 टू द पावर n सबसेट्स जनरेट करके उनका सम निकालना कितने लोगों से हो जाएगा. क्विक +1 इन द चैट. ये तो होना चाहिए फॉर टुडेज सेशन. अगर ये नहीं हो पा रहा है तो शायद आज का सेशन आपके लिए थोड़ा एडवांस्ड है. इफ यू आर गिवन अ सेट, उसके 2 टू द पावर n जो सबसेट्स है, उन पे इटरेट करके उनका सबसेट का सम निकाल पाना, ये आपसे होना चाहिए. दिस इज अ रिकर्शन प्रॉब्लम, अ बैक ट्रैकिंग प्रॉब्लम. यू शुड बी एबल टू राइट इवन रिकर्सिवली और इटरेटिवली. एक बिटमास्क वाला कोड भी आता है ना, दैट यू bitmask से you can iterate over all the subsets and you can go through that. That's also an idea that you can possibly use. ठीक है. तो bitmask से you can go through all of its subsets and generate all the sums. तो अगर आपके पास n इक्वल टू 20 एलिमेंट्स का एक एरे है, यस bitmask इज मोर एफिशिएंट. अगर आपके पास n इक्वल टू 20 का एरे है, तो आप 2 टू द पावर 20 सबसेट्स जनरेट कर पाओगे. ओके. नाउ अगर मैं आपको पूछूं x इक्वल टू 2, राइट, दैट्स द करेक्ट इंक्लूड एक्सक्लूडेड. एवरी एलिमेंट कैन बी आइदर इंक्लूडेड और एक्सक्लूडेड. x इक्वल टू 6, ठीक है, is a subset there which is having sum equal to 6. For this, what is the answer? Yes or no? Yes, right. एक सबसेट है ना यहाँ पर जिसका सम 6 है. ठीक है. सिमिलरली अगर मैं यहाँ पर देख कोई वैल्यू दे दूं, दैट इवन इफ द सबसेट्स आर लार्ज, इफ आई गिव यू सम वैल्यू लाइक 10 टू द पावर सम, कुछ ऐसा एक नंबर दे दूं, in the 2 to the power 20 subsets that you are generating, will any one of them have this sum? Yes or no? Can you check this by generating them and then going through them and checking if it any one of them is equal to x or not? Can you do that? चेक हो जाएगा. ठीक है. तो ये चीज होता है सिंपल बैक ट्रैकिंग का आइडिया. बैक ट्रैकिंग या रिकर्शन या ब्रूट फोर्स का आइडिया. बैक ट्रैकिंग और ब्रूट फोर्स का आइडिया बेसिकली, राइट. knapsack dp नहीं भाई. knapsack dp, if somebody is coming here and saying dp and all, you don't understand the concept कि dp में values को small होना पड़ता है. It doesn't work when the values are big. 10 to the power 9 होता है तो dp नहीं लगा सकते. ओके. यहाँ पर 20 है इसलिए सॉल्व हो रहा है. वैल्यूज जब स्मॉल होता है तभी डीपी लग पाता है. ओके. तो 2 टू द पावर 20 सबसेट्स हम ब्रूट फोर्स से जनरेट कर रहे हैं. ओके. दिस सेशन बी अवेलेबल ऑन यूट्यूब? नो, दिस विल नॉट बी अवेलेबल ऑन यूट्यूब लेटर ऑन. ठीक है. नेक्स्ट इज, व्हाट इफ वी डोंट हैव n इक्वल टू 20, n इक्वल टू 40 वाले केस. दिस इज वेयर मीट इन द मिडिल ट्रूली शोज इट्स पावर. ठीक है. n इक्वल टू 20 है, तुम्हें ai is up to 10 to the power 9 and you are given x equal to some value. तुम्हें चेक करना है क्या ये वैल्यू एनी ऑफ द सबसेट का सम होगा कि नहीं होगा. दिस इज व्हाट यू हैव टू डू. There are 40 elements. You have to find any subset having sum equal to x is present or not. टू सम एक गलत प्रॉब्लम. तुम तो टू सम में दो एलिमेंट का सम इक्वल टू एक्स है कि नहीं होता है. यहां पर कोई भी सबसेट टू सम में, तो देखो ओ ऑफ एन स्क्वायर ऑप्शंस पॉसिबल है, इसमें 2 टू द पावर n ऑप्शंस पॉसिबल है ना. सो इट्स वे हार्डर. सो n इक्वल टू 40 में तुम्हारा क्या हो जाएगा? 2 टू द पावर 40 तुम सबसेट्स जनरेट करोगे विच विल टीएलई, क्योंकि 2 टू द पावर 40 कितना होता है? 10 टू द पावर 12 होता है. Now you might ask me, Vivek, how did you calculate it so fast कि ये इतना होता है? सिंपल है. 2 टू द पावर 20 is close to 10 to the power 6. ये याद रखना. ठीक है. 2 टू द पावर 10 is actually equal to 1024, which is equal to 10 to the power 3. So 2 to the power 20 will be 10 to the power 6. So 2 to the power 40 will be 10 to the power 12. consider 2 as 10 cube, 2 cube. नहीं, I think this is a better estimate. ठीक है? So problem statement is basically हमें सबसेट सम्स में से कोई एक एरे का सारे सबसेट जनरेट कर रहे हैं, उसमें कोई सम इक्वल टू एक्स है कि नहीं, हम ये चेक कर रहे हैं बेसिकली. ठीक है, दैट्स द क्वेश्चन. तो 2 to the power 40 सारे सबसेट अगर हम जनरेट करेंगे तो उसमें से तो फिर हम चेक करें कि उनका सम क्या है, फिर उसमें से किसी का एक्स का वैल्यू है कि नहीं, ये चेक करने में तो टीएलई आ जाएगा. एवरीबॉडी एग्रीज दैट टीएलई हो जाएगा ये चीज. if we try to do something like this will be a TLE, because इतना तो नहीं कर सकते. 2 to 10 to the power 12 तो पास नहीं करता है. Pruning is something which basically removes non obvious things, but pruning से जरूरी नहीं है कि कुछ better हो जाए. I don't think pruning helps in this problem. Okay, pruning मतलब क्या होता है? Some spaces which like is obvious कि इसमें जाने का कोई सेंस नहीं बनता है, पर वर्स्ट केस कॉम्प्लेक्सिटी चेंज नहीं होता है. राइट, तो देखो आइडिया क्या है. ठीक है, आइडिया क्या है कि अगर सपोज तुम्हारे पास यहां पर 1 2 3 4 होता, एक ऑप्शन था दैट वी कुड हैव जनरेटेड 2 to the power 4 सबसेट एंड उसमें चेक करते. राइट, द मेन आइडिया ऑफ मीट इन द मिडिल इज कि इसको दो सेट में डिवाइड करो, 1 2 3 4. ठीक है, दो सेट में डिवाइड किया, हाफ ऑफ, अप्रोक्सीमेटली हाफ ऑफ. इसके सारे सबसेट सम जनरेट करो. व्हाट इज द सबसेट सम? एक तो एम्प्टी. व्हाट आर द सबसेट्स? एक 1, एक 2, एक 1 2. Are these the subsets of this particular set? Yes or no? इसके सबसेट जनरेट करो, एम्प्टी 3 4 3 4. नो, दिस इज नॉट एक्स्ट्रापोलेटिंग बाय एनी. देखो तो अभी ध्यान से. ठीक है, इसके कितने सबसेट आए? 2 to the power 2. इसके कितने सबसेट आए? 2 to the power 2. ठीक है, now if we would have tried to generate all possible subset of this particular thing, okay, we would have gotten a lot of different subsets, things like empty, things like 1 3 4, things like 1 2 3 4, things like just 1 and 4. All these subsets would have been there in the all possible subsets. Yes or not? Yes or no? If we would have generated all possible subsets of this one, so we would have gotten all these subsets in the final answer. But then we are not doing that because this will be a very large set, because we want to do it for 40. So we are dividing it into two parts, 20 20 approximately, if it's like bigger, if it's a smaller set. What we would be having is, how is this set getting generated from these two is what we will try to look at. If we try to combine each element with each element of this other side, see, we'll start getting elements over here. Empty plus empty will get empty. Empty plus 3 we will get 3. Empty plus 4 we will get 4. Empty plus 3 4 will get 3 comma 4. Right? Over here, 1, if we try to combine it with all, you will see that you will get 1 1 3 1 4 1 3 4. Right? So if I take each subset here and try to combine it with each subset here, will we get all the subsets over here? Because here there is 2 to the power 20, I mean 2 to the power 2 for now. 2 to the power 2 multiplied by 2 to the power 2 is this final set, 2 to the power 4. Right? if there would have been 40 elements here, there would be 20 elements, 20 elements. Here there would be 2 to the power 20 elements. Here there would be 2 to the power 20 elements. And then if you merge 2 to the power 20 multiplied by 2 to the power 20, for each element on the top side, you will getting another element from the other side. So there will be 2 to the power 40 elements. But we don't want to generate this because 2 to the power 40 elements is something we can't deal with. Now, what we are looking for is, in this final set, is there a number with value x, with a sum x? Is there a number, is there a set which has sum equal to x? Now, what are the subset sums that you are trying to get over here? It's nothing but the subset sums over here, which is nothing but, let me write it in a different color. 0, 1, 2, 3 combined with 0, 3, 4, 7. If you combine this with this, if you add them, you are getting this empty one. If you 5 plus 3 is nothing but 0 plus 3 over here as a subset sum. 1 plus this 3, 4 is same as 1 plus 7, this set which has 8 as a sum. So all pair product from this subset sums, all pair product will give you all subset sums of the original set. Is this something you are able to make sense or not? This is the main idea of meet in the middle. If you build the subset sum array of this first one, 0, 1, 2, 3, and if you build a subset sum array of this one, these two things, if you combine all pair product, 0 plus 0, 0 plus 3, 0 plus 4, 0 plus 7, 1 plus 0, 1 plus 3, 1 plus 4, 1 plus 7, 2 plus 0, 2 plus 3, 2 plus 4, 2 plus 7, 3 plus 0, 3 plus 3, 3 plus 4, 3 plus 7. All these possible sums is what 2 to the power 40 sums will be over here in this set. Because that's how the set is getting generated. All pairs are giving you a new set. Does this make sense? Okay. So that's what we are looking for. That if all pair subsets is what you are trying to find in this sum, and that is what is generating over here. If you want to check if there is a sum x or not, another strategy that you can use is you can just loop through each element over here and check, okay, you need x, let's say equal to 6. If this is 0, 6 minus 0 should be present over here. If this is 1, 6 minus 1 should be present over here. If this is 2, 6 minus 2 should be present over here. 6 minus 2 is present, 4, which actually represents this set. So 2 combined with 4. 2 is coming from here. 4 is coming from here. See, there is a subset which has sum equal to 6. So we can iterate on one, and on the other one, we can search for map, search in a map whether that particular value is present or not. Can we do prefix sum with prefix sum is not required, right? Every element check in the other map if that value is present or not. Now, a very interesting question is, why is it called meet in the middle? Because if you think about it, it's like there are two different sets that will combine and generate a big set. We want to find what half comes from this side and what half comes from this side. So we are iterating on the value some y over here, and total sum minus y should come from this side. That's how we are trying to say it's basically meeting on the middle. Okay. So if there is a size of 40, yeah, so 3,4 is 7. You can get it by getting this 7 plus 0, empty from this side and 3, 4 from this side. That will generate the set 3,4. Right? Now, some of you are saying that, Vivek, can we divide it further? The problem is right now we are able to traverse on one and check as a map on the other side, right? Whether that value is present or not. If you have 3 such partition, if you know that this is X, how will you check whether you can make something from the rest or not? That's not possible, right? Like we don't have some data structure that can check with both the values together, 2 sets together. whether some combination will give it that way or not. So it's always optimal to divide it into two parts only. Yes, that's correct. Now there is a very interesting question that Stricker is asking. Should n always be even? Tell me, yes or no? No, right? Because think about this case. 1, 2, 3. I can divide it into two parts which are almost equal. I can generate all possible subset sums. And then all pair products, 0 plus 0, 0. 1 plus 0 is just taking 1. 1, 2 plus 0 is like just taking 2. 3 plus 0 is like taking 1, 2 and nothing from this. 3 plus 0 is like taking 3 and nothing from this. 3 plus 1 will be like 3 and 1. 3 plus 2 will be like 3 and 2. 3 plus 3 will be taking all of them. So you will get all the 8 elements here. But we will not generate this. We will just loop on the smaller one and then search on the other side, whether that value is there or not. Right? We will loop on this and check. If you want to search for 6, you will say, hey, if I need 6, here there is a 0. So I need 6 here. It's not present. Here there is 3. So 6 minus 3, 3. Is this present? Yes. I can generate 3 plus 3, which is nothing but the set 1, 2. And from here it's 3. So combine them together, you will get the sum 6. Does the idea of meet in the middle make sense to everyone now? What we are trying to do in meet in the middle. Just curious, can we extend this to something like divide and conquer? That's what I'm saying. Divide and conquer in two parts is fine, but then three parts, what exactly are you searching for? It's no longer clear. So no, meet in the middle is just two parts division. Okay. Yeah. So time complexity, you basically get the square root sort of like two parts. If you have two parts, 2 to the power 40 got converted to 2 to the power 20 into some O of n 20 times iteration and stuff. That is fine. It's not a big issue. If you have some 20, 30 multiplied, that's not an issue, right? 2 to the power 40 got converted to 2 to the power 30, 2 to the power 20. That's really good. Clear, everyone? This is the power of meet in the middle. Okay. It should be called divide from middle. Okay. Another like very, very interesting way in which this is used is, I don't know if you have thought about this problem. Have you seen LinkedIn? Have you all used LinkedIn? Have you seen that you are shown if you are this person, this is your first connection, this is your second connection, and then some nodes are called third plus. Have you seen this on LinkedIn? That some people are written first, second, third plus what connection level they are at. Okay. When you have millions of people, like million, let's say million people. Okay, million people. And there are friends, like follower relationships everywhere between them, like connected or not. There is, let's suppose there is a graph, whether this person is connected to this is connected to this is connected to this. There is a big social graph, right? And there are million means 10 to the power 6. I think LinkedIn has more users. But then let's say there is 10 to the power 6 nodes. Do you understand that potentially to check if you are in second order or first order, that's very, very hard to do in a graph. Like you have to figure out, say this is user X, you are user Y, find out what level of connection you are at. You are essentially trying to find the shortest path between the two nodes. Now you are saying, can't we do BFS? And that's a very interesting idea, that can't we do just a BFS that, hey, there is this node, go to its first level nodes, go to its second level nodes, and then possibly there is a third level. I think very, very basic way would be to check if there is any node over here. If you are not first, if you are not second, then you are third plus. So that you can check. But then this second level nodes would be very high. This would be like every node possibly. Like it can happen that you have all nodes. And I'm just giving this a rough estimate. This would be around 10 to the power 7 or 10 to the power 8, maybe. Okay. So queue size, even if not queue size, every second somebody is clicking. So how do you dynamically compute that for so many pairs? Number of pairs is 10 to the power 12 or even more, 10 to the power 14, 10 to the power 16, 18 pairs. How do you calculate it for all pairs? Because somebody can click anytime and you will have to do such a long BFS for everyone. That's a very complex thing to do, right? So the way LinkedIn optimizes this is it uses meet in the middle. Okay. What it does is basically it stores your first level connections in some sort of cache. There is another one, like say you want to check with another person. There is his first level connections in a cache, and you can check if there is some pair which are up connected among themselves. Because the second level will be a very huge thing, but the first level connections are small for most people, right? You will have how many connections? Say maximum 500 connections, right? Or most people have like around 100 connection possibly. I don't think more than that, right? 100, 200 connections. Okay, on an average user. On average user here, there will be 100 and 200 connections at max, right? So it's just two set and you have to find if there is any edge between any one of them. Okay, between two sets. This is an easier problem to solve. This can be solved in a distributed way very fast. So that's why this is the problem they try to solve. And either you will be in this, so it's first connection. If there is any pair that is connected, then you will be in the second order connection, right? Sorry, my mistake. If there is anything common between them, if there is a set like this over here and there is a first level connection set over here, if there is any node that is common, then it's a second order connection. Does this make sense? If the first level connections of this and this has something in common, then this is second level connection, right? So having 100 on this side and 100 on this side, you can just loop on one and check if in the other set there is that same value present or not. So second level connections becomes order 100 kind of a thing or a order 1000 kind of thing instead of order 10 to the power 6 kind of thing. If it is present, then it's a second. Firstly, you can check if it's first order. That is directly easy. That if you have a list of connections, then you can have both of their cache list and then you can check from this side, is there any common connection or not? That way, this is second order connection. And if it is not, you can just print third plus. And that's why, my friends, they have third plus. They don't try to go for fourth because that's hard to calculate, right? Clear everyone? वो compute करने में उनकी जान निकल जाएगी. तो they don't do that. क्योंकि किसी का second order निकालना पड़ेगा. That's very hard. Clear everyone? This is the idea of meet in the middle, and this is how it's actually used in real world also. I mean, it's a very, very useful idea, particularly in graph searches. Graph search, when you have source to sink, you know both of the nodes, you can do bidirectional search. There is bidirectional Dijkstra, there is bidirectional searches that are available. This is one of the examples of that, meet in the middle. Okay. Clear? Okay. Now let's try to solve some problems and see if you guys are able to like identify how to use whatever we have learned. Okay. At least in the idea, because today, I think more than coding, let's try to solve some problems where there is some interesting meet in the middle possibility. I don't know. So let's do drill. How many of you know what is a drill class? This is possibly a drill class for AZ students. But then how many of you know what is drill? I think there are students who are outside AZ also. Like I have also posted about this class on Telegram. So I had told that I'll do that in the last live stream, Lead Code live stream. So there are students who are not there in AZ also. So how many of you know what is a drill class? I need some minus ones. किसी को तो minus one लिखो भाई. Yeah. Okay. So drill class is basically I'll show a problem. I'll give you some time to think about it. Okay. And then we'll discuss what we should be doing in this. Because on YouTube, I don't do that much of drill classes, right? That's the internal AZ concept. Okay. So we'll take first problem and I'll have a timer. I'll give you 5 minutes to think about the problem and then we'll discuss the problem, right? And I'll obviously give you the link also if you want to. The first problem is this. Let's try to read it and see if you can understand the idea. Okay, I'll also share the link. Okay, so time starts now. Try to think about this problem. See if you can progress and think about this. Once you have read the problem and you have understood it, type in a +1. If you have solved it, then type in a +2. If you think you have gotten the solution, type in a +2. Okay. दोनों में डिवाइड करें. Okay. I see many of you have thought about the idea correctly only. Let's try to discuss this simply. And this is a like direct, I think many of you would have able to understand that once, since we are in the realms of, probably since we are in the realm of divide and mid in the middle, you are able to detect it very easily. But then अगर मैं general देता तो शायद तुम लोग नहीं detect कर पाते, right? That this is a meet in the middle. That right now we have to find number of quadruplets which are having XOR not equal to 0. So first thing that I generally think about this, ये not equal to 0 count करना बहुत hard है, equal to 0 count करते हैं, complement. So W can take anything between 1 to A, 1 to B, 1 to C, 1 to D. So total number of quadruplets that are possible is A into B into C into D. Is this true? Yes or no? Total number of quadruplets minus number of W, X, Y, Z, where XOR equal to 0. ये करेंगे तो क्या हमें non equal to 0 मिल जाएगा? Right? That is what I am first thinking, because not equal to 0 is a very tricky term, right? तो वो नहीं करना है, बस not equal to 0 वाले हमें चाहिए. तो equal to 0 निकालना is easy, like it's a direct thing. Equal to 0, not equal to 0 is like anything can be there, right? So number of quadruplets that has XOR equal to 0. Okay, so then W XOR X XOR Y XOR Z, ये value को हमें 0 करना है. So we divide it into two parts, W XOR X and Y XOR Z. Okay, what are the feasible values that are there in this? We can create some sort of map that, okay, how many pairs of values of W comma X gives us 1? Say 0, how many pairs will give me 0? Say 30. How many pairs of values of W comma X gives us the XOR as 1? Say 5. And something like this, we can build a map that how many pairs have a XOR equal to 0, how many pairs have XOR equal to 1, how many of pair have XOR equal to 2, and so on. This will be nothing but order A into B, yes or not? We will just loop on all possible values of W, again nested loop, all possible W values of X, whatever is the XOR, increase it in the frequency map, right? Yeah. Then you have W XOR Z. Okay. So similarly, इस पे भी you will find 0 कितने सारे लोग का है, 1 कितने लोग का है, and so on. Right? You will get for every value how many pairs have this particular XOR. Now we go through this one and say कि भाई अगर W XOR, if this has a XOR equal to 0, to make this equal to 0, this also has to has the same XOR. So every pair that has 0 can combine with all the 30 pairs that has XOR 0 and it will still remain 0. So answer plus equals to 30 into 50 plus. There are two pairs which will have XOR equal to 1. They can combine with these 5 pairs which has XOR equal to 1 and they will both result in final XOR as 0. So this will be possible quadruplets. Plus so on, सब पे loop चलाओ, corresponding values के map में add करते रहो. If it is not, then it will become 0. So product will become 0. Simply get this sum, that's your answer. Okay. But yeah, if we find based on non-zero, then it would be 3 cases, na? Non-zero, no. Non-zero is only when it doesn't combine with itself. That's it. So you will have to do this. How to prevent duplicates? यहाँ तक समझ में आ गया? Yes or no? Okay. Next, there is a very interesting twist. बताओ क्या twist है? Duplicates. Pair duplicates. Divide by 2? Not really. Not really. फ्रीक्वेंसी चेक कर सकते हैं ना? Didn't get it exactly. What do you mean by that? Yeah. You can't really generate the subsets, right? तुम generate करके duplicate check नहीं कर सकते, generate तो नहीं कर सकते ना, because then it will become big. वही तो problem है. वही तो problem है कि वो नहीं कर सकते. We can find distinct minus 0 when distinct. Okay. Any other ideas? Okay. Let's say these are A, B, C, D, है ना? Like, let's try to think about how can we generate non-duplicate quadruples already. ठीक है? Think about it. Say A is, मतलब without loss of generality, we can sort A, B, C, D, right? मतलब we can assume that A, B, C, D is sorted. Right? A is equal to 2, B is equal to 3, C is equal to 4, D is equal to 5. We can assume this because they are just 3, 4 values, right? It doesn't matter which one is what. We can sort them. Okay. Now, any quadruplet that is there, W from this, X from this, Y from this, Z from this, let's say, can we say that we will only allow W less than equal to X, less than equal to Y, less than equal to Z? We will only allow this. Yes. तो भी सारे सबसेट जनरेट हो जाएंगे. Can we still generate all possible quadruplets with this restriction in place or not? कर सकते हैं. If you had this constraint that W can be anything, X can be anything, Y can be anything, Z can be anything in the range, like obviously less than equal to A, less than equal to B, less than equal to C, less than equal to D. And let's suppose you generate bunch of unique quadruplets. There are bunch of unique quadruplets that you generate. Even if I add this extra condition, you will still generate that same unique quadruplets, because the smallest one will take from A, second smallest one will take from B, third smallest one will take from up till C, and fourth smallest one will take up till D. Clear? Yes or no? अरे भाई हाँ ना, कुछ बोलो भाई. Okay. The values in W will be same in D, right? In D as in, no, W will come from A, Z will come from up till D. We lose track when combining. कोई बताना टॉपिक प्लीज. टॉपिक तो मीट इन द मिडिल है भाई. उधर बहुत लेट ज्वाइन किया आप क्लास के लिए, बट ठीक है, सुनो आंसर. या W less than equal to X and Y less than equal to Z is implemented in for loop, but how to do that when you are traversing both? That's a very good question. We would be generating lesser quadruples than before, but they will be distinct. Is that what you're saying? Yes, we'll be generating lesser, but they'll all be the same unique distinct ones. एक एग्जांपल देखते हैं ना, एक एग्जांपल देखते हैं. ठीक है. Suppose you choose from here 1, from here 3, from here 2, from here 3. ठीक है, ऐसा कुछ quadruplet तुम generate करते हैं. Is this a possible quadruplet? Let's say 0. Okay, इसका ZOR 0 है. Okay, if I say that I am restricting it with this, there will still be a quadruplet which is nothing but 0, 1, 2, 3, which satisfies each of their restrictions and will have ZOR equal to 0. So जब ये generate हो रहा होगा तो ये चीज count हो जाएगा अपने आप, this quadruplet that you are trying to think of. तो if we always maintain things in sorted order, जो possible है सब generate होगा for sure, क्योंकि smallest वाला इससे less होना ही है, second smallest इससे less होना ही है, all possible things will get generated automatically. So we just need to maintain this while generating. Correct? Okay. Now, how do we generate this? ये कैसे करें? I mean, you might understand that when you are generating this, you can maintain that, okay, x is less than equal, x is greater than w. ये तो इधर for loop चलाते time करना बहुत easy है. Doing this part individually over here is easy. That when you are looping on w, you will maintain that you loop on x only bigger than w's. Similarly, generating this is very easy. You will only allow z values bigger than y. And then all possible that is generated will get generated over here. But then how will you maintain that x is also greater than equal to y? How will you maintain this across the set is the main question. ये कैसे करेंगे? Somehow use lower bound. Lower bound किस पे करोगे? I mean, there are different y values, right? I'm not sure for each XOR value, also maintain X value came from. Maybe let's think about it. Okay, let's see if we can do it or not. ठीक है, ध्यान से देखना. I'll just try to do a very simple implementation and let's see if we can do it. ठीक है, somehow if we can manage doing this. Count XOR comma max. That pair itself can have a lot of different values, right? 3000 plus 3000. The map will become very large, isn't it? I mean, like, or there will be like a lot of sum to check from. Sarthak, I understand what you are saying is correct. Max min we can try and maintain, but it will become very complicated, right? Can we do something better? Something easier where you don't need to track min and max. Okay. Let's try something. ठीक है, थोड़ा सा code करते हैं. Let's try to see what my code is doing. I don't know if I'll be able to get this on. Okay. I think we can just simply remove some classes. Right. This was last class basically. 2048 designing. Okay. We check every time less than equal to condition is required or not. Okay. Let's see. Okay. I'm just giving you an example. Just try to see this and see if you're able to understand this or not. Okay. So ठीक है, कुछ मैजिक कर दोगे आप अभी? हो सकता है, ठीक है. So we are getting 4 values and I need to sort them anyway, so I'm just taking the 4 values in an array only. So A B C D मेरे को sorted मिल गया है. V of 0 is A, so it's like V contains A B C D in sorted order. यहाँ तक समझ में आ गया सबको? Is there anything to explain in this? I mean, this is not even needed. 4 वैल्यू लिया, लोड करके सॉर्ट मार दिया, ABCD वैल्यू लोड हो गया अरे में. इज दिस क्लियर? Let's try to save all possible C or D values in a set and assuming, sorry, C, when I say C, W, X, Y, Z, okay, all Y's, W will come up till A, Y will come up till B, sorry, X will come up till B, Y will come up till C, Z will come up till D. यहाँ तक क्लियर है? Okay. So all possible Y's or Z value will be nothing but integer. Y equal to possibly from 1. Y will be less than equal to C, Y plus plus. And then we can loop over integer Z equal to, we can start from 1. Yeah, C is nothing but V of 2. I'm just writing C for now. I'll replace it with V a little later because we have just done in that way so that you can relate it to the original problem. Z is equal to, should we start from 1 or should we start from Y? Because we assume that W is less than equal to X, less than equal to Y, less than equal to Z. So Z should start from Y. Z is less than equal to D, Z plus plus. And then, I mean, this is not, instead of this, I'm making a map that possible values of Y, XOR, Z plus plus. These are all possible values of Y, XOR, Z. Does this make sense? यहाँ तक सब कुछ clear है? I'm just generating all possible Y, XOR, Z. Okay. Let's start magic now. Unique values. Yes, these are all unique pairs, right? These are all unique pairs. Okay. Now let's start the magic. Okay. Now we will loop over integer X equal to 1. X is less than equal to X will be less than equal to B, X plus plus. These are possible values of X, right? What are the possible values of Y? What are the possible values of W? One to A or 1 to X? Which one? Isn't it this? Either of them, right? It should be in A or X because X का जो value है उससे नीचे तो होना ही पड़ेगा, and it should be less than equal to A, right? W plus plus. So these are all possible X comma W that are getting generated. Let's say integer answer equal to 0. I'm just counting all possible answers, and obviously answers can be long and all at this point. I'm just keeping it in integer. You can make them long later on. Okay. So for every X, we are looping on all possible values of W. And if we want the number of pairs with XOR equal to 0, answer plus equals to the number of possible is this possible? Y XOR X should be same as X XOR W, because then only you will get XOR equal to 0. This many number of quadruplets will have XOR equal to 0. Does this make sense? But then there is a problem, right? If X goes to 2, you can have Y equal to 1 possible things in this map. So remove them before you go to X equal to 2. Assuming X is your Y, remove the contribution of the things that has the XOR as this. Okay, let me explain. Let me explain what is happening here. ठीक है, ध्यान से सुनो, ध्यान से सुनो. This is the main magic. ठीक है, एक ही लूप में काम खत्म हो गया. सुनो सुनो सुनो, don't get hurry. Okay, X equal to 1, हम लोग क्या कर रहे हैं, देखो ध्यान से देखो. This is a very interesting idea in itself, and I'm trying to explain you that how to remove double counting and distinct things. ठीक है, ये चीज, this is a core idea in itself. ये समझ गए तो हर बार सही होगा, नहीं तो नहीं सही होगा कभी भी. जब भी ये distinct quadruplets, distinct pairs जो भी काउंट करने बोलेगा, this is the idea. ठीक है, for some problem जो एक होता है स्टैंडर्ड, उसमें distinct नहीं चाहिए, मुझे distinct indexes चाहिए, तो ये टेक्निक यूज करना पड़ता है. ठीक है, listen to me very very carefully. कहाँ गया भाई? हमने क्या करा, फॉर एवरी पॉसिबल एक्स हम लोग लूप चला रहे हैं, राइट? व्हाट इज हैपनिंग है, तो देखो प्रॉब्लम सिंपल यही कि तुम y और z का लूप चला के सारे पॉसिबल पेयर्स जनरेट कियो, उनके साथ x एंड w का सारे पॉसिबल पेयर जनरेट करो सच दैट x इज लेस देन इक्वल टू y, ऐसा हो. क्योंकि y x इज लेस देन इक्वल टू y, ऐसा वाले सारे पेयर्स को आपस में कंबाइन कर दो. दैट्स व्हाट वी नीड टू डू, राइट? क्योंकि x के कॉरेस्पॉन्डिंग w तो हमने उससे छोटा जनरेट किया ही है, w इज लेस देन इक्वल टू x एट ऑल पॉइंट्स. इसमें भी हमने जनरेट किया कि y इज लेस देन इक्वल टू z. वी हैव जनरेटेड थिंग्स इन दैट वे ओनली इन आवर कोड कि y इज ऑलवेज लेस देन इक्वल टू z, z इज ऑलवेज ग्रेटर देन इक्वल टू y, w इज ऑलवेज लेस देन इक्वल टू x. ये तो हमने जनरेट ही वैसे करा है, तो दिस टू विल ऑलवेज बी ट्रू. हमें बस चाहिए x शुड बी लेस देन इक्वल टू y. तो हमने अभी y सारे वैल्यूज अलाउ किए, बट जैसे ही x का वैल्यू 1 से 2 में जाएगा, उसके पहले हमने जो y का वैल्यू 1 अज्यूम करके इसमें डाला था सेट में, उन सबको हटा देंगे. y का वैल्यू 1 अज्यूम करके किसको किसको डाला था, जब y का वैल्यू 1 था, y का कुछ भी वैल्यू था, से इंटीजर y इक्वल टू x, जो x अभी जो है वो अज्यूम करके हमने जो y को यहां पर इंसर्ट किया था, उन सबको हमने इससे रिमूव कर दिया मैप से. सो दैट नाउ द ओनली पेयर्स दैट आर अवेलेबल इन दिस मैप आर विथ द y's that are bigger than the current x, ताकि जब x अगले लूप पे जाए तो उससे ग्रेटर देन इक्वल टू पे अवेलेबल रहे ओनली. क्या टेक्निक समझ में आया ये? अब ये समझ में आ रहा है क्या हो रहा है? तो अगर मैं तुम्हें एक एग्जांपल दिखाता हूं, एक एग्जांपल दिखाता हूं तो पूरा क्लियर हो जाएगा. ठीक है, एक एग्जांपल देखते हैं तो समझ में आ जाएगा प्रॉपर. ठीक है, सपोज 3 3 3 3 है. ठीक है, ओके, x इज अप टिल 3, y इज अप टिल 3, z इज अप, सब कुछ 3 तक जा सकता है. ठीक है, तो देखो जब हमने ऑल पेयर जनरेट किया y कॉमा z, तो y जब 1 है तो z का वैल्यू 1 हो सकता है, 1 कॉमा 2, 1 कॉमा 3, 2 कॉमा 1, 2 कॉमा 2, 2 कॉमा 3, 3 कॉमा 3. क्या y के ये सारे y कॉमा z के ये सारे पेयर्स जनरेट होंगे, यस और नो? फिर हमने क्या बोला, x इक्वल टू 1 पे तुम चेक करो, जब x 1 है तो w का वैल्यू क्या हो सकता है, 1 ही हो सकता है, उससे छोटा ही होना पड़ेगा. तो 1 कॉमा 1 w का w, ये अब हम लोग w कॉमा x से कर रहे हैं. ठीक है, तो 1 कॉमा 1 जनरेट हुआ, 1 कॉमा 1 के कॉरेस्पॉन्डिंग किसका, जो भी तुम्हें इसमें मिलना है जिसका जोर सेम है, ताकि जोर का वैल्यू 0 हो जाए, वो तुम्हें मिल जाएगा. अब जब हम x इक्वल टू 2 पे जाएंगे, उसके पहले हम क्या करेंगे, जब x 1 वाले जो हो गए इनको डिलीट करना पड़ेगा हमें, क्योंकि इसमें z y का वैल्यू 2 था, y का वैल्यू 1 था इन सब में. तो जब x इक्वल टू 2 होने वाला है उसके पहले y इक्वल टू 1 अब यूज नहीं कर सकते, बिकॉज x हैज टू बी लेस देन इक्वल टू y। तो अगर x का वैल्यू 2 पे जाने वाले है उसके पहले y इक्वल टू 1 वाले इनवैलिडेट हो जाएंगे मैप से। तो दैट इज व्हाट वी आर डूइंग। जब x इक्वल टू 1 का आंसर निकाला उसके बाद y इक्वल टू जो उस x का था उनको डीएक्टिवेट कर दिया, फिर x इक्वल टू 2 पे गए ताकि यहां पर 2,1 2,2 जनरेट हो। तो इसके साथ सिर्फ यही वाले कंबाइन होंगे। देखो इसका जो थर्ड वाला जो सेकंड वाला है वो हमेशा इससे बिगर रहेगा। And this is how we are always generating sorted quadruplets. And sorted quadruplets will always be unique. क्या अब टेक्निक समझ में आ रहा है या नहीं आ रहा है? यस, बाय डिलीटिंग y इक्वल टू एक्स को, जो y इक्वल टू एक्स जो था अभी करंट वाला उसको हटा दिया, तो x जब आगे जाएगा तो पुराने सारे y छोटे वैल्यूज डिलीटेड रहेंगे। इज दिस आइडिया मेकिंग सेंस टू एवरीवन? कैन आई हैव सम क्विक प्लस वन? देखो यही डिफरेंस है भाई। ये आइडिया जैसे तुम सोच पाओगे तब तुम लाइक एक मतलब डिफरेंशिएटिंग कॉन्टेस्ट में एक क्वेश्चन ऊपर हो पाएगा कि हाउ टू मेक दिस यूनिक जनरेटेड। ये यूनिक का अपना एक इंटरेस्टिंग आइडिया है डुप्लीकेट रिमूव करने का। ठीक है, ये इन्हीं पे 5-6 आइडियाज को ये सब मिला मिला के क्वेश्चन बनाते हैं लोग, और कुछ नहीं है। Zor value of different pairs can be same, so it's possible that neat future answer might be deleted. नो नो, हम लोग तो सिर्फ सॉर्टेड वाले क्वाड्रप्लेट्स को काउंट करने की कोशिश कर रहे हैं, राइट? आप हमेशा कुछ मस्त सिखा देते हो। हाँ भाई, अब तुम मेरे सेशन में आया, कुछ मजा नहीं आया सीख के, तो फिर तो क्या ही फायदा। So for every problem requiring distinct elements, distinct quadruplets, distinct pairs, distinct triplets, you can always generate them in sorted order. And दो सेट में तुम्हें sorted order generate करने का यही तरीका है। ठीक है, एक और प्रॉब्लम सिमिलर आइडिया पे देखते तो पूरा क्लैरिटी बिल्डअप हो जाएगी, राइट? पूरी क्लैरिटी बिल्डअप हो जाएगी। एक और प्रॉब्लम देखना है, बहुत सिंपल सिमिलर प्रॉब्लम। यस और नो? एकदम क्लासिक प्रॉब्लम है, शायद तुमने सबने देखा होगा ये प्रॉब्लम। ठीक है, I deliberately wanted to show this to you all. Yeah, this is a foursome problem, right? Standard foursome problem. You can't solve it? नहीं नहीं, ऐसा नहीं है यार। ये सबमिशन कब के देख रहे हो? 2019 के। तुम अभी कहाँ बैठे हो? थोड़ा दया करो मुझ पे। मैं भी कभी नूब था यार, ऐसा नहीं है। ओके, तो हमें 4 इंडेक्स का सम ये चाहिए। ऐसा तुम काउंट ही कर दो अभी के लिए। मैंने तो जब से कोडिंग स्टार्ट करी है प्रो ही हुआ। हाँ, तब तक तो प्रो हो गया था। ओके, इसमें इंडेक्स प्रिंट करना है। ठीक है, यू हैव टू प्रिंट इंडेक्सेस, बट हमें अभी सपोज काउंट करना है हाउ मेनी क्वाड्रुपलेट्स आर, हाउ मेनी 4 इंडेक्सेस आर देयर हुज सम इज इक्वल टू 15। ठीक है, से हमें ये करना है n इक्वल टू x, फाइंड नंबर ऑफ इंडेक्सेस हुज सम इज इक्वल टू 14। तो कैसे करेंगे? सेम आइडिया, 4 डिस्टिंक्ट इंडेक्स चाहिए। ये y और z ये सब चीज इंडेक्सेस हो जाएंगी और कुछ नहीं। ठीक है, सो ए बी सी डी 4 इंडेक्सेस इन इंक्रीजिंग ऑर्डर सिलेक्ट होगा। ठीक है, C and D should be different indexes. So C जो भी start हो रहा है, D should be greater than C. So C plus 1 से n तक, for all possible pairs, you can make that sum as, ये sum हम बना सकते हैं C और D से. Clear everyone? अब दूसरा तरफ क्या करेंगे? B से B वाले पे लूप चलाएंगे. A should be less than B. Okay? And अगर हमें टारगेट सम ये चाहिए तो आंसर प्लस इक्वल्स टू, I mean, I'm trying to generate everything. Sorry, this should start from 0. I'm trying to generate all possible pairs. I mean, it will be valid only from there, but I'm generating all possible pairs. ठीक है? या माइनस, सॉरी. ये होगा A एंड B के जो भी सम आए उसको सब्ट्रैक्ट करेंगे X से, बचा कुचा फ्रीक्वेंसी में जितनी बार है वो पेयर्स पॉसिबल है. अब बिफोर मूविंग B फॉरवर्ड फ्रॉम 0, अगर B का वैल्यू 1 है, मतलब सॉरी, यहां पर हमें C का वैल्यू शुड बी बिगर देन B. C का वैल्यू शुड बी बिगर देन B. तो इंटीजर C इक्वल टू जब B था जो वैल्यूज पे, उन सबको हटाओ यहां से. पहले C का वैल्यू जब B के बराबर था, उन सबको मैप से डिलीट करो. ठीक है, उन सबको मैप से डिलीट कर दो. उसके बाद जो A एंड B आएंगे उसमें C एंड D के जो पेयर्स होंगे वो B से बड़े ही होंगे. हमने C के B के बराबर डिलीट कर दिया, बिकॉज इन द प्रीवियस प्रॉब्लम वी हैड टू डू लेस देन इक्वल टू. इसमें स्ट्रिक्टली लेस देन चाहिए. इन द लास्ट क्वेश्चन वी हैड डन W इज लेस देन, कहां गया वो ड्राइंग हमारा? In the last question, we had done W is less than equal to X, less than equal to Y, less than equal to Z. But in this question, we are using 3 indexes, A, B, C, D. So A, B, C, D, A should be less than B, less than C, less than D. तो जब B पे iterate कर रहे हैं तो C cannot be equal to B also. So before finding A's for B, we are removing C equal to B वाले चीजें. जो बराबर है उसको भी हटाओ, है ना? So anything that is equal will get removed. ठीक है? एंड देन फाइनली हम पहुंच जाएंगे उस जगह पे जहां पर जो भी फ्रीक्वेंसी में जो भी पेयर्स अवेलेबल है, जिसका सम अवेलेबल है, उन सब में C विल ऑलवेज बी बिगर देन B. वही इंडेक्सेस अवेलेबल होंगी सिर्फ. क्लियर? दिस इज द आइडिया इन विच यू कैन रिमूव डुप्लीकेट्स. दिस इज द मेन आइडिया ऑफ जनरेटिंग थिंग्स इन डिस्टिंक्ट ऑर्डर. डिस्टिंक्ट, ये जो डिस्टिंक्ट टर्म दिख रहा है ना बार बार इधर उधर, डिस्टिंक्ट पोजीशन, ये इसका मेन ट्रिक है. ये जानोगे तो होगा, नहीं तो फिर तो मौत ही आ जानी है. CF प्रॉब्लम लिंक, CF नहीं था, हैकर रैंक पे था. टोटल -0. टोटल इज, in the last problem we got distinct with XOR 0. How did we get distinct quadruplets with non-zero XOR? How many distinct quadruplets exist? That's also a good question. उसमें भी same चीज कर दो बस, instead of like using a map, just do plus plus. Everything will have a contribution. XOR का value 0 होना जरूरी नहीं है. That's all. That's how you can count them. Okay. आइडिया समझ में आया? तो ये प्रॉब्लम सॉल्व हो पाएगा? क्या राइट, सेम जोर वैल्यू के लिए होंगी। भैया ये रिकॉर्डिंग मिल सकती है? ओके, आई विल चेक विद द टीम वंस। आई थिंक एजेड के साइट पे अवेलेबल करा दूंगा मैं। आई सी, आई पोस्ट इट ऑन द टेलीग्राम। ठीक है, इन केस यू मिस्ड सम पार्ट। एट कोडर लिंक, ले लो भाई लिंक। क्वेश्चन तो सामने ही है। Just search meet in the middle code forces, meet in the middle, different blogs will come up. You can solve from there. हाँ हाँ, कम सब सबमिट तो करना ही है ये सब क्वेश्चंस। इसे थोड़ी दिखा रहा हूँ। पढ़ना हो जाए तो +1, सॉल्व हो जाए तो +2। मेरे को अभी बार बार बताना पड़ रहा है। हाँ, एजेड वालों को बताता हूँ। हम लोग का हर वीक तो एक एक ड्रिल क्लास हम लोग करते ही है, जिस भी टॉपिक पे कर रहे हैं, सेम एज दिस टुडेज क्लास। तो पढ़ना हो जाए तो +1, सॉल्व हो जाए तो +2। That's what we keep as a setup. अराउंड 50s के आसपास ही रहते हैं मैक्स प्रोबली। इंडिविजुअल टाइम का क्या है? सम मैक्सिमाइज करना है राइट? इंडिविजुअल टाइम का सम मैक्सिमाइज करना है, बट यू हैव टू बी लेस देन इक्वल टू टी इन इट्स टोटल वैल्यू। Join now. I'll check with the team once. यप, कुछ तो लोअर बाउंड अपर बाउंड सोचो। Yep, subset sum less than equal to t. Yeah, that's the correct statement that you have understood. Largest subset sum with value less than equal to t. Is that the question? Find the largest subset sum having sum less than equal to t. Perfect. कैसे करोगे? डायरेक्ट क्वेश्चन एट कोडर कॉन्टेस्ट बिगिनर का लास्ट क्वेश्चन। कैसे करोगे? ओके, बाय द वे यू ऑल नो राइट, आज एक 11 o'clock पे एक यूट्यूब लाइव स्ट्रीम भी है, हैव यू सीन दैट? ओके, अभी डाला नहीं है मैंने, डालता हूँ। रोड मैप वाला जो एक पार्ट है उसमें थोड़ा ऐसे चिल ही है, उससे चिल डिस्कशन ही है। आई जस्ट गो थ्रू व्हाट ऑल टॉपिक थिंग्स आर देयर एंड क्या क्या टॉपिक पढ़ते हैं लोग, थोड़ा मतलब बहुत बार लोग पूछते हैं, तो आई हैव लाइक एडेड ऑल द टॉपिक्स इन दैट रोड मैप एंड उस पे यू कैन डिस्कस अ लिटिल। n equal to 20 and 20 subset, yes, somebody is asking कि कूपन कोड, भाई कूपन कोड मेरा वो AZ VG स्पेशल जो है वही एक कूपन कोड है, और कोई कूपन कोड नहीं है मेरे पास, ठीक है। I'll put that in chat, सब कुछ नहीं है मेरे पास, जो मैंने उस पर टेलीग्राम यूट्यूब पे डाला होगा वही होगा। आई डोंट थिंक देयर इज एनी कूपन कोड एज सच। ओके, divide into two sets, one set find max value less than equal to t minus x using lower bound, yep, correct, yeah, exactly, करेक्ट। तो क्या है इसमें, आइडिया सिंपल है, सेम एज द लास्ट प्रॉब्लम, सेम एज द टू सबसेट सम, कुछ नहीं करना है। अगर हमारे पास सपोज 1 2 3 4 है एंड द सबसेट सम हैज टू बी लेस देन इक्वल टू t इक्वल टू लेट्स से 7 6 है ना, t इक्वल टू 6, तो हमें क्या करना है, हम सपोज 1 2 लिए तो उसके सबसेट सम को जनरेट किया हमने, 0 1 2 3, दूसरे साइड पे क्या आया 3 4 का, 0 3 4 7, दीज आर द सबसेट सम्स। अब मुझे सबसेट सम 6 तक चाहिए, तो अगर 0 लिया तो ऑन द अदर साइड आई कैन एटमोस्ट टेक लेस देन इक्वल टू 6 माइनस 0, तो लेस देन इक्वल टू 6 माइनस 0 क्या है 4, so the best I can make is 0 plus 4 which is 4, for 1 the best I can do is up go till 5, तब भी I can take 4, तो 1 plus 4 is equal to 5 I can do best, इस पे I can do best 2 plus 4 which is 6, तो I can make 6 as a sum as well, तो 6 possible हो जा रहा है, I can just do lower bound and find the sums, clear? We are iterate, so we need to find, इस पे से we have to choose x, इस पे से we have to choose y, x plus y is the subset sum, so it has to be less than equal to t, and we have to make x plus y as large as possible. Is this the question? So let's say we are looping on x, so we know the value of x, है ना, so I just need to find y is should be less than equal to t minus x, and y should be as large as possible. So I can sort the subset sums. There are 22 to the power 20 subset sums. I can sort them. Okay. And I can just finally find out largest y less than equal to this particular value. This is a problem of something called as lower bound and upper bound. पता है सबको कैसे करते हैं? Lower bound, upper bound करके upper bound निकालेंगे इस value का and then go back one step. Find upper bound, go back one step. That's the strategy that you use for such problem. Clear all? अपर बाउंड क्या देता है, स्ट्रिक्टली बिगर देन टी माइनस एक्स, पहला वैल्यू, एक घर पीछे जाएंगे तो सबसे बड़ा वैल्यू विच इज लेस देन इक्वल टू टी माइनस एक्स मिल जाएगा मुझे, दैट्स हाउ यू यूज अपर बाउंड इन सी प्लस प्लस। दिस इज सेम एज 1755 ऑन लीड कोड, ओके, मे बी नो नो 60 के ऊपर डिपेंड करता है, आई थिंक नो, ओके। क्लियर एवरीवन? व्हिच मैकबुक आर यू यूजिंग? कोई तो भी मैकबुक यूज कर रहा हूँ भाई, M2 वाले ही कुछ कर रहा हूँ, एयर ही यूज करता हूँ मैं तो। हाउ टू डिवाइड द एरे, दिस एरे, शुड वी राइट द कोड फॉर दिस, एक बार लिख भी लेते हैं फटाफट, क्यों नहीं, वाह 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 वाह, क्लियर तो है बट लिखना भी सीख लो कोड, लोग मेरे को सब आके बोल तो देते विवेक हो गया कोड हो गया, होता तो नहीं है उसके बाद, है ना, क्या बोला है क्वेश्चन में, कहाँ गया हमारा क्वेश्चन? टी दे रखा है, ए आई दे रखा है, एन दे रखा है, एन टी दिस। ओके ठीक है, सेम इनपुट है एकदम। ऑब्वियसली लाइक इंट हमें नहीं चाहिए, लॉन्ग लॉन्ग चाहिए, बट देन आई थिंक आई विल बी फाइन विद दिस। ठीक है, तो वेक्टर सॉर्टेड ऑल सबसेट सम। ठीक है, मैं इसको एक वेक्टर दूंगा, इट शुड बी एबल टू फाइंड मी all sorted, all subset sums in a sorted order. ठीक है, this is what it should return. So integer n equal to arr dot size. I'll just do a bit mask idea. Integer mask equal to 0. Mask is less than okay. For integer I equal to 0, I is less than n, I plus plus. For this particular mask, you will get a subset sum if mask and 1 shifted by I is there. That means ith element is present. So sum plus equals to ARR of I. This is one of the sums. So vector of int answer, answer dot pushback, sum sort answer dot क्या है? Answer dot begin, answer dot end, and then return the answer. This is how you generate all possible subset sum. एक array को लिया, उसके सारे सबसेट पे इटरेट करा. दिस इज बिटमास्क वे ऑफ इटरेटिंग ऑन सबसेट्स. यू कैन आल्सो डू विथ रिकर्शन. यू कैन लूप ओवर इट्स बिट्स. देखा, जो जो बिट ऑन है वो सारे एलिमेंट सबसेट में है, उसको उस सबसेट सम को तुमने आंसर में पुश बैक कर दिया, सॉर्ट कर दिया सारे सबसेट सम्स को एंड रिटर्न कर दिया. So now you have a method that gives you sorted sums of two side. So given an array, I have to make two sets. Vector of int parts. There are two parts. I'll loop through all the array. Okay, and I'll just push it into one of the parts alternately. This is how you split in almost half part. Okay, go through the array for every element, put it into one of the halves alternately. पहला वाला 0 पे जाएगा, फिर 1 पे जाएगा, फिर 0 पे जाएगा, फिर 1 पे जाएगा, 0 1 0 1, तो almost equal divide हो जाएगा basically. This is a very nice way of splitting the two parts. ठीक है, फिर हम क्या करेंगे, ये वेक्टर ऑफ इंट एक एक साइड पे रहेगा a, which is sorted all subset sum of part से 0. ठीक है, and then similarly I can use b for part 1. Then we need to find whether if we have to iterate on one. So for auto, like best, we need to find the best sum only, right? Do we need to find the value also? The best sum. So integer best is equal to possibly 0, because if we don't take anything, we'll get 0. So for auto, v in b will loop over all elements of v. B auto it is equal to lower bound. Since it's sorted, we can use upper bound. Upper bound in the a, we'll do begin a dot end. And since we have a target sum t minus b, इससे just बड़ा वाला value निकालो. If it is not equal to a dot begin, we have to go back one step, it minus minus, and this value is the best possible value. So best is equal to max of the current best, comma, you had v from b plus star of it from a side, or else you don't have anything. No possible. So just skip it. Okay. If you reach a value where you're not even getting something over here, probably you should break, but I'll leave it going on there, because अगर ऐसा value आ गया जो जिससे सारे values bigger ही है, तो उससे smaller value exist नहीं करता फिर. और and anyways b is also sorted, so you will not get any value. So this is there, and then you can possibly print cout best. Right. Yeah, I think this would be interesting. Let's see. Oh, we did not max it. And अच्छा, we didn't even take the input yet. I mean, input ले भी क्यों रहा है? Right. So 33 will be the answer. Right. 100 तक best तुम 33 बना सकते हो. For this, possibly the answer should be 0. Yeah. Is there a need to sort B? Yeah, we don't need to sort B. A बस sorted होना चाहिए. But then a function same ही use कर रहे तो it doesn't really matter. Yeah, we can take any half. We can take any half. Yeah, it's fine. Can we sort original part and take half part to? Yeah. नहीं, sort करके the subset sums should be sorted, not the original array. That is not required. The subset sum should be sorted, so you can find in the subset sum, not in the original sum, original array. Okay? समझ में आया ये? एक फाइनल प्रॉब्लम. ठीक है, let's take this. This was asked in Texas OA this year. हाँ ठीक है, कहीं पर भी रहे. हाँ, meet in the middle has been asked in online assessments before. Okay. There are 2n elements. We'll have 5 minutes. Think about this. I've sent the link, right? Yeah. Think about this problem. Similar idea. लग रहा है मीट इन द मिडिल, बट कैसे होगा ये? दो पार्ट में स्प्लिट करना एक साथ कैसे हो चुका है? मीट इन द मिडिल तो है ही है, क्योंकि 30 पे तो नहीं होगा, टीएलई हो जाएगा 2 to the power 30. सो वी हैव टू डू 2 to the power 15 somehow. हाउ विल यू डू दैट? ध्यान से सोचते हैं, ठीक है? ध्यान से देखो. सेम आइडिया. देयर इज अ बिग एरे वेयर यू हैव टू डिवाइड इनटू आइदर ए और बी. दो पार्ट में स्प्लिट कर रहे हैं. And basically we have to make a minus b, the sum of a minus sum of b, go as minimum as possible. Is this the question? Okay. Can we say it as we need to make this close to zero? Like either on the negative side or on the positive side. Is that the same thing? A minus b, sum of a set. Every element will go to either a set or b set. A minus b needs to be close to zero as much as possible. Okay. Every element has two choice. Go to A, go to B. We'll divide into two parts. Okay. If element goes to A, we know that it will contribute positively to this. If it goes to B, we know it will contribute negatively to it. So that's what we will generate. Ki bhai, for a particular part, if something goes to A, how much positive minus how much negative we are getting for the elements in the B. What is the A minus B for this part? All possible A minus B's for this part. Similarly, all possible A minus B's for this part. Now, when we will combine two elements, their A minus B will also get combined. Yes or no? So there are two parts. From the first half, you are generating A minus B values. From second part, you are generating A minus B values. And their sum, all pair sum will give you all possible A minus B values, and you have to make it close to zero. So for a particular X here, every element when taken to A will positively contribute to this A sum. We have to make the subset sums as close as possible, right? If you take it to B, it will negatively contribute to this sum, to this value. So parts में भी तो वही होगा ना. Parts में if it gets selected to A, you say it's positively contributing. If it's not selected to A, if it's selected to B, we'll say it's negatively contributing. तो इस part का जो 15 elements है, there will be 2 to the power 15 possibilities जहां पर some element has gone to A, some element has gone to B, and then the final contribution to their corresponding A's, B's difference will be some X. यहाँ पर some X. So we have to correspondingly find some Y such that X plus Y is as close to zero. Is that what we need to find? For a particular X, find the Y such that X plus Y is as close to zero. फिर से कुछ लोअर बाउंड अपर बाउंड लग रहा है इसमें. जीरो से एक्स प्लस वाई जस्ट ग्रेटर देन जीरो निकालो, जस्ट लेस देन जीरो निकालो. शुड वी कोड दिस? कोड करते हैं. देखो अभी ध्यान से. कोड देखे बिना क्लियर नहीं होगा. क्या आपने ए माइनस बी बिल्ड कर रहे हैं फॉर बोथ पार्ट्स? यस, ए माइनस बी वैल्यू फॉर बोथ पार्ट. सो ऑल सबसेट सम्स की जगह ऑल ए माइनस बी सम. तो अगर उसका मास्क ऑन है तो वो ए में जा रहा है तो पॉजिटिवली कंट्रीब्यूट कर रहा है. एल्स अगर जीरो है तो वो नेगेटिवली कंट्रीब्यूट करेगा. सिंपल ए माइनस बी वैल्यूज जनरेट हो गए, सॉर्टेड. हो गए ए माइनस बी वैल्यूज जनरेट. इधर ही कोड करते हैं, हम लोग बाद में उसको लीड कोड में डाल लेंगे, ठीक है? एरे लेकर के उसको हमें टी नहीं चाहिए, वी हैव टू जस्ट मेक एब्सोल्यूट पार्ट्स टू दैट. तो ओके. सो वी जस्ट नीड टू मेक इट क्लोज टू जीरो. टारगेट वैल्यू क्लोज टू जीरो बनाना है हमें. तो जीरो से जस्ट बड़ा वाला वैल्यू निकालो, राइट? इफ IT is not equal to A dot end, then something bigger exists. तो वो बिगर वाला क्या है? बेस्ट इक्वल टू, बेस्ट तो यार मतलब इन्फिनिट हो गया, एज इन 1E9 ले लो अभी के लिए. एंड बेस्ट इक्वल टू मिनिमम ऑफ बेस्ट कॉमा abs of whatever you are getting from B plus whatever just bigger than minus B V is available in A star of IT. और अगर इट्स तो ये जस्ट बड़ा वाला वैल्यू मिला, जीरो से जस्ट बड़ा जो भी वैल्यू पॉसिबल है, ठीक है। एंड देन अगर नहीं है तो जीरो से पीछे जाकर के जस्ट छोटा वाला वैल्यू भी मिलेगा। इन सब में से जो भी ऑप्टिमल आएगा वो आंसर है हमारा। यही तो करना था, बस a माइनस बी के टर्म्स में सोचना था एंड मेक इट क्लोज टू जीरो इज द ट्रिक इन दिस प्रॉब्लम। a के सारे सब a माइनस बी सारे चीजें जनरेट किए, इट शुड बी मिन, हाँ मिन, राइट, दिस शुड बी मिन, वी नीड टू मेक इट मिनिमम पॉसिबल। Zeroth index of sorted value will work? No, not necessarily. Because there are negative values as well, right? Why did we take two parts alternately? Why added here? Because each part में अपना A और B में splitting हो रहा है, A और B में splitting हो रहा है. Best way to combine those splitting is what we are trying to find. कि best possible matching क्या होता है उन दोनों में. हम लोग सारे का A B splitting कर पाते, that is there. But then in this case we are splitting into two parts. दोनों में अपना अपना A B में splitting हो रहा है और उस splitting को merge कर रहे हैं तो भी A प्लस हो जाएंगे आपस में, B प्लस होंगे और सब्ट्रैक्ट होगा फाइनल। तो वो चीज अभी भी इंटैक्ट है बिकॉज जो A था वो प्लस हुआ है, जो B था वो माइनस हुआ है। सेकेंड पार्ट में भी वही हुआ है, दोनों को ऐड करोगे तो प्लस 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 माइनस माइनस आपस में ऐड होकर प्लस हो जाएंगे, तो इट्स लाइक टोटल पार्ट बीइंग सब्ट्रैक्टेड। एंड टू इक्वल पार्ट्स तो ये पार्ट कोड का कर ही दे रहा है। चला के देखते हैं इनपुट पे फटाफट, कहाँ गया भाई इनपुट। तो जीरो पॉसिबल हो जा रहा है, ऐसा नहीं भाई, ये इनपुट अच्छा लग रहा है कुछ मुझे, है ना। कितना है, 4 वैल्यूज एंड दिस, देखते रन करके। तू दे पा रहा है ये? ओह आई कॉल्ड द रॉन्ग नेम। आ रहा है कुछ कुछ? एब्सोल्यूट तो ऑन फाइनली करना है, राइट, नॉट ऑन इंडिविजुअल। नहीं तो इंडिविजुअल ए पे जो आया, ए पे जो वैल्यू है वो ए माइनस बी का वैल्यू है, ए का एक पार्ट का, एंड सेकेंड पार्ट का जो है वो बी माइनस ए वाला, ए माइनस बी वाला जो वैल्यू है वो सेकेंड पार्ट पे लूप, इस पे लूप चलाया। आई मीन द नेम्स आर रॉन्ग, ठीक है। ए बी मतलब समझ लो कि ये दो पार्ट का बस ऑल पॉसिबल ए माइनस बी, कैपिटल ए माइनस कैपिटल बी वैल्यू जनरेट हुआ है, ठीक है। तो इस पे देखो वो कैसे करके निकाल रहा है इस इनपुट पे, ठीक है। ध्यान से हम सोचते हैं एक बार, वैसे आ कैसे रहा है, लेट्स सी एक बार, लाइक आई विल जस्ट ट्राई टू सी वंस, है ना। दिस इज द इनपुट। सो ऑल्टरनेटली वो बना रहा है से इसको दो पार्ट में स्प्लिट करेगा, 3 7 और एक 9 3, ठीक है, दो पार्ट में करेगा। नाउ वी आर ट्राइंग टू स्प्लिट दिस इनटू two different alternate parts, like either this will be in A, this will be in B, this will be in A, this will be in B, ऐसा कुछ हो सकता है, something like this, or one of the optimal ones will be both of this will be in A, which will lead to 3 plus 7, which is nothing but 10 on this side. Both of them are in A, and in this case let's say both of them are in B, so here there will be a value minus 9 minus 3 minus 12. Now 10 will combine with 12 to give minus 2 as the total sum, which is absolute of which is 2, which is the best possible value. If we try to generate all possibilities, let's try to say both goes to A, 10, this goes to A, this goes to B, so 10 3 minus 7 minus 4, this goes to B, this goes to A, so 4, and both goes to this minus 10. Similarly here will be some values as well, and we'll get them sorted obviously, right? Some goes to A, some goes to B. The difference is what we are maintaining in the arrays. And that is what will get combined. And we need to make it closest to 0 as much as possible. That's the idea. 12 minus 6, 6, 12. I think that will be the values anyways. Okay. So for 10, it will try to combine with something that gives me closest to 0. It will combine with 12 so that I get the value 2. 4 will try to combine with something closest to it, what makes it closest to 0. So 0 minus 4 will be 4. The upper bound of it is 6. So you will get 0 combined with 6, which is also giving me 2 in this case. Does this make sense? The 2 is the best thing that you are possibly getting. When you combine, basically what is happening? Here you have bunch of values A1, A3, which has been taken in A minus B1, B3, B2, B4. These were 2 and 4 were taken in B's. In the second part, you are getting, let's say, A5, A6, A7 got into A, B6, B8 got into B. When you add these two values, these are both in A now, and these are both in B. That is how the addition is working. Correct? That's how this idea is working. Okay. Try 36 minus 36. Let's try. Giving 0. Because one will happen is, one will have 36, one will have minus 36. This will have two possibilities. 36 goes to A, so it gets 36, or it goes to B minus 36. In this, it will have a possibility that it goes to A, so minus 36 or 36. 36 will best combine with minus 36 to give you 0. No, we have to make, just a sec, we have to make minimum possible, right? Didn't get it exactly. Why? If I take both of them in the same set, is it non-empty? Yeah. Oh, both have to have sizes of n. Oh, there is another restriction that both have to have sizes of n. Okay. So we'll do that also. Thanks for pointing this out. I didn't see that while reading. Simply what we'll do, when you build the partition, we need to count how many elements are there in A. LM in A is equal to 0. When it goes to A, let's suppose element in A gets plus plus, right? We know how many elements are there in this A. So it is a pair now that this many elements are there in A and this is the sum. This is what you are pushing it in the answer now, that there are these many elements in A and this is the sum. Okay. There are these many elements in A and then there is this many sum. And then you sort the answer. So now when you have some number of elements, when you are going through, I'll just use it over here. For all possible things, you are basically going through how many elements are there in A and what is the difference of A minus B, all possibilities. So when you are going through an element in B, okay, you know that you need to only check with elements having V is a pair. It has how many elements there are there in A and how many? What is the sum? So it has to have n minus that number of elements in A in the other part, and you can try to get it best closest to 0. So what I'll do is I'll search with n minus V dot first. This is the thing that you want to get it closest to in this. Star of the first plus the first. If it's equal to n, then only this is feasible. Right? The total number of elements we are maintaining in both the parts is this. 2 into n. No. Total in A. Total in A has to be n. Push back. There is n. Oh, there are 2n elements, right? So n minus V dot first, which is pair. Is this now working? It should be minus 72. Okay? Absolute value pucha hai, okay, 72. Right? So you basically match only the thing that we changed in this code is, along with this, we are tagging that here one element went to A, here 0 element went to A. Here one element went to A, here 0 element went to A. Now, total 1 elements needs to happen. So 1 will only combine with zeros. That's what you are maintaining in the pairs. Okay, that's what we maintained in the code. Yep. Can you upload the recording footage on YouTube? Okay, I'll try. मेथड्स में पेयर बना के सेंड करना पड़ता है सर. यस. नहीं, upper bound needs pairs. So make pair. It cannot automatically decide what type it is. Yeah. Okay. Cool. Chalo. I think this should be it for today. I hope you guys enjoyed something new today, and I hope did you guys like the session today? मजा आया? Okay, चलो. Good. चलो, meet in the middle पे सीखना हो गया अच्छे से. That will be all from my side today. Can first question be explained? I think you can see it on the recording.